Thank you. So let's go to the next talk, which will be given by Krzysztof Kamiński, who will tell us about another type of minor solar system bodies, but this time the artificial ones. Okay, so Krzysztof, please, you can share your screen.
Okay. Okay, good afternoon. My name is Krzysztof Kamiński, and I would like to tell you a few words about the influence of Earth artificial satellites, especially large constellations of satellites, on astronomical observations. Well, the fact that satellite trails can contaminate astronomical images has been well known for many years. But recently, in 2019, the interest in that topic sparked because of the publication, well, not only, but mostly because of the publication of this particular image that was quite famous and wide covered in media. This image was taken during the Dark Energy Survey on a 4-meter telescope with a large field of view camera over 2 degrees of the field of view. And as you can see, there are about 19 bright satellite trails recorded. Well, to be honest, it was quite a special circumstance. We can see here a batch of Starlink satellites that were just launched recently, a few days before, and were still on very low orbit. So they were brighter and packed together very tightly. Nevertheless, this sparked some concerns among astronomical community about the future of ground-based optical observations. Well, overall, the number of Earth satellites is growing, was growing, and is growing, and will be growing since the beginning of the space age. As we can see here, it reached about 22,000 recently. But we need to remember that this data shows only unclassified satellites, so there are probably a few thousands more, and only objects larger than 10 centimeters are actually cataloged. And as we can see at the end of the graph, there's a rapid growth, mostly due to Starlink constellation development. And there are some abrupt jumps due to collisions and explosions. It's worth noting that most of the cataloged objects are space debris, non-operational satellites, or parts of the satellites or rockets. So it is expected that the growth will continue and will be faster than ever before in the coming years. So it's it's not surprising that it's concerning astronomical community. And here is an example of an analysis done 2 years ago that the authors were summarizing the future planned satellite constellations, large satellite constellations. The largest still is the SpaceX Starlink constellation, but there are several other quite substantial. Together, they will put into orbit over 20,000 new satellites, and so this will more than double the existing number of observed catalog satellites, and this does not take into account any other programs. Here we can see also very important information about the influence on astronomical observations. Fortunately, all of those satellites are very low above the Earth, the ground. Yeah? Not more than 2,000 kilometers. So these are all low orbits. And in such situation, even if we have thousands of satellites on such a low orbit, we see very minor percentage of this group. Unfortunately, all of them will be relatively bright targets between 4 and 8 magnitude. so the concern, well, remains. In the case of Starlink satellites, the SpaceX was cooperating with astronomical community to a certain degree, and they have developed new models of their satellites, new designs, to decrease the observed magnitudes of those satellites. So on the left, we can see the DarkSat design, which was just made by painting the brightest areas, antennas, or on satellite. But it was abandoned. I presume that it was because of overheating. Then they developed visors that are casting shadows on brightest parts of the satellite, and it was a successful design, and I think they are using it till now. Overall, the observations have shown that initial batch of Starlink satellites at this shell, because there will be 3 shells of those satellites, is at about 5 magnitude, and the newest one are slightly dimmer at 7 magnitude. It's better, but still very bright for astronomical observations. So, what is the situation right now? Here is the simulation showing you all the known satellites from one single location, but when the sun is very hidden very well below horizon, so close to midnight. In that situation, we will never see many satellites on low orbits. There are only a few examples, the red dots here. But majority of satellites, especially above the 30 degree above horizon, so the most used area on the sky for astronomical observation, majority of satellites are in higher orbits, especially geostationary belt is prominent here. Some of them, as a part of satellites, are hidden in Earth's shadow, but majority is visible, and its surrounding. So we can see that close to midnight, large constellations will not be a problem, but the situation is quite different when we are near twilight. When the solar, here the plot is prepared for when the sun is below 12 degrees below horizon. So that's the typical moment of starting or ending astronomical observations. And as you can see, there is a group of red satellites on low orbits. So these are the, among these, we have some Starlinks and other satellites from constellations. But the overall number is not growing too much, fortunately, because we had previously 650 satellites roughly, and we have now 800 satellites. So even adding every new satellite constellation to this picture will fortunately not make it much larger. It will be around 1,000 satellites. Well, it's quite a lot, but fortunately, most satellites are below horizon. But positions is not everything. Magnitudes are also important. So in this plot, we can see the distribution of observed brightness of satellites. These are this is again a simulation for a randomly selected location on Earth. And on the left, you can see the magnitudes of low satellites, low Earth orbit satellites. And these are, so among these, there will be those constellations, and constellations will be actually in here. So one of the brightest of this group. Generally, there is a slight trend so that higher orbit satellites are dimmer. But if we include angular velocities, then the picture complicates because on average, brighter, lower satellites are moving faster. Therefore, the trails will be dimmer. Then in the situation of geostationary and, for example, navigational satellites that are moving slower and are dimmer. So because the situation is getting complicated, we are developing a new service that will be ready, I hope, in a few months for everyone to use. We call it Satellite Trail Predictor, and the service is focusing on predicting and also calculating for past observations what satellites will cross your field of view. And here is an example for this famous image with satellites. Our prediction, you can see it's not very great because satellite orbits are not very well determined in this case. They were still changing. But it was good enough to predict it and perhaps prevent observations of this field during that time when the batch of Starlink satellites was crossing it. But it's not only a matter of planning observations, it's also sometimes interpreting observations. Knowing satellites might be important for that purpose. Here is an interesting example. In 2020, there was a publication published in Nature Astronomy about the observation of very distant galaxy candidate at a redshift of 11. And authors were collecting spectral observations of this very distant galaxy. And it's so faint that on individual spectra, we don't see the spectrum at all. Only adding all those spectra together revealed the very faint spectrum of this distant galaxy. But one spectrum is different, and we can clearly see a spectrum here. One image contains a visible, not very high signal to noise, but still very bright compared to normal. And the authors suggested that it might have been a very lucky observation of a gamma ray burst. They concluded it's the most likely explanation. But then other astronomers were starting to discuss with this discovery a little bit, because this was done using very narrow slit spectroscopic observations. This was Mosphera's spectroscope on Keck telescope. And with a very narrow slit, the probability of observing a gamma ray burst is very low, of course. And some argued that the probability of a satellite is much higher. So we decided to try to verify it and used our software for calculating whether we find any candidate for a satellite that might have been passing the slit. Here is a field of view of the telescope, and the blue lines are slits of the spectrograph, so it's a multi-slit spectrograph. And the nominal orbit of the satellite that we think was the cause of this is in black line. So it's slightly above the position where the flash was observed. But in case of Earth satellites, their orbits are not usually very well determined. And if we overplot the 1 sigma, 2, and 3 sigma level, then we can see that it might have been as well in the position where the flash was observed. More so, orbits of this particular satellite published later were even closer to the correct position, and no other flash was observed with the spectrograph with any others on any other slit. So it's a very probable explanation. This was a Russian satellite, well, actually a Russian fourth stage of a rocket, heavy lift rocket, proton rocket. So it's a space debris. It's not used anymore. It's a passive object. So we decided to observe it. And here's an image, one of our images, On the image, we determined the magnitude of this satellite. So it was varying between 8 and 10 magnitude. And in this case, it was perfectly matching the brightness of the observed flash, because the satellite, although much brighter than the spectra would suggest, was visible only for a fraction of a second, passing across the slit of the spectrograph. So everything, the brightness, the position, the position angle, was matching the properties of the flash, and we of course published it. So it's an interesting example of a rare, quite a rare event in astronomy, where the distance is revised by 20 orders of magnitude from the most distant gamma ray burst to one of the closest distant object in this case. And that's an important, I think, example of the problems that we will have to face in the future. And that's an important indicator that some methods of dealing with that must be developed in the future, in terms of planning observation, in terms of interpreting data, or in terms of removing satellite trails from images heavily contaminated, as the famous example have shown. So that would be all from my side, and thank you very much for your attention.
Thank you, Krzysztof, for your talk. I'm sure that many of us did not realize how big problem we are going to have with such satellites. So now we can, now there is a time for a few questions, if there are any. Yeah.
Can I have one? Tomek Kluwak from Poland.
Yes.
Krzysztof, it was very impressive, especially the system you are planning. That means that help observers to avoid observation of regions where the satellite can be present. My question is: do you plan to have a solution to online, let's say, in real time API to ask your service to have the information immediately available, or it is just something that I need to put into the I don't know, web service or something like this to have this information? Can you elaborate a bit, please?
So initially, it will be a graphic interface, so a web page that you can input your data and get information about all satellites passing the field of view for a selected amount of time. So initially it will be only that way, because the amount of computation necessary is relatively high, and we are still thinking about how to deal with that problem, perhaps pre-compute something. And so even with relatively fast algorithms that we are using, orbital algorithms, STP models, then it's quite time consuming to calculate it for if we are searching blind for any possible satellites. Yeah? So that's the reason why initially definitely it will be only graphical interface, and individual cases will may be checked, but then we'll see. Perhaps we will develop it further, and perhaps we will find some computational power to do it.
Krzysztof, this is Richard Schmuty. There is an opportunity here too, though, and that is when, for example, a geostationary satellite moves into the Earth's shadow, and this happens around September 21st and around March 21st. We can actually watch the satellite dim as it moves through our atmosphere and get important information about our own atmosphere. I talk a little bit about this in my artificial satellite book that I published about 10 years ago.
Mhm.
Do you have any comments on that?
Well, I haven't done any such observations before. We were observing we've done some observations when the satellite was actually hidden in the Earth shadow, and we have observed that sometimes it's quite abrupt, dimming, sometimes is longer. So definitely the weather yeah, will affect it, the stage of the Earth atmosphere. That's definitely what's affecting that. Yeah, that's true. Mhm.
Thank you.
Okay, and we've got a few questions on the chat. The question from Stefan is, what happened in 2007, sudden and steep increase of debris? This was one of the first slides.
Mm-hmm. So here we have two events, 2007 and 2009, and one of this is a collision between Iridium and a Russian Cosmos satellite that produced several thousands of observed debris and many more unobserved, of course. And the other event is the largest one, is the missile test, Chinese missile test. They intentionally destroyed their own satellite, but it was quite on a relatively high orbit, and we still have many debris flying around the Earth, and it was the largest such event up to date.
Okay, and another question is, can your service be accessed programmatically? How difficult are calculations for rather larger fields of smaller telescopes?
Yeah, well, it's not complicated mathematically, but only the processing power is yeah, it's quite processing consumed, let's say. For now, we plan only using allowing people to use web interface, human web interface. So for the initial period, no programmatic access, but then we will definitely discuss the possibility to perhaps release more functionality of the service. We have to see whether our servers will manage the interest in this topic or not. Yeah, that's one factor that we are not sure yet.
Okay, thank you for your answers. Okay, if there are not any more questions, so now there is a time for a short break.